Hello? Okay. Thank you all for coming to the Zero Knowledge Proofs panel. So we've been doing like Zero Knowledge Proofs for like 5 or 6 years, and like today we gathered together some of the like key people pushing forward Zero Knowledge Proof technology. So I'm gonna let them introduce themselves. So Vitalik?
Yeah, hi. So I'm Vitalik. I've written a couple of blog posts and like implementations trying to explain various zero-knowledge proof protocols. I contributed exactly one idea to the original Plunk paper, so I've kind of been on the sidelines watching this amazing space grow, and it's been really fun the last 5 years.
Hi everyone, my name is Ye. I'm the co-founder of Scroll. At Scroll, we are building a bytecode-level compatible ZKEVM. So we are using a lot of very advanced, like zero-knowledge proof algorithms to generate proof for our ZKEVM. We are using a lot of fancy optimizations to build out the whole circuit. And personally, I'm more doing ZK research and some protocol research.
Hello, I'm Jordi Baylina. I'm the technical lead at Polygon zkEVM. And besides that, I am also the author of CIRCOM and SnarkJS, among many other things, but this is the main work related to ZK.
Hi, Eli Ben-Sasson. I fell in love with cryptographic proofs more than 20 years ago when I was doing my postdoc at MIT, originally on things called PCPs, probabilistically checkable proofs. Since then, wrote a bunch of academic papers, which led to things like Zcash, of which I was a co-founder, and StarkWare, of which I'm a co-founder. So.
Thank you, Eli. So my first question is for you, Eli. So over the last couple of years, there's been a lot of things that we've wanted to do with ZKPs. Like the first main use case was Zcash. And like the performance limitations there were, it was a very small circuit, and the performance limitations were quite important design consideration. And it's like 5 or 6 years later, and we have like zkEVM, and we have like all these other like incredibly complicated things. Like, could you talk about like what's the blocker for us when we try and make ZK applications?
So I think today the blocker is not the generation of proofs. It is the connecting, having end-to-end integrations and tooling for developers, because the proofs are not generation of the proofs, even on existing hardware, can be done very efficiently. So I think that's the main blocker, really just having an end-to-end system with a lot of tooling around it that works from the developer cycle to testing to deployment to integrations for end users. I think that's the blocking thing.
Okay, that makes sense. My next question is for everybody. I'm curious, what is the thing that you want to do that we're currently just not able to do? Do you have some examples of applications you want to build that it's just not possible to build right now?
For me, I would say I like to compare, I'm an electrical engineer, so I like to compare the things in between software and hardware, okay? So we are in an era of writing hardware. So we say circuits. Circuits is okay, we write hardware not with transistors, we write hardware with constraints or polynomials. Okay, but we are in the era where to build things, we build electronics. We want to do a calculator, and then we take some components, some chips, we connect them together, and we get a calculator. Okay, but now we are starting. We start inventing, or we start working with processors. That means that we will enter to an era of the software. So where the people will be able to just program normal statement or a normal circuit or a normal program in a regular software language, in Rust or in C or in things like that. We are at this moment where we are transitioning from one stage to the other. So for me, the interesting thing and the thing that I want to see and that we are start to seeing now, but this is, I think, what will revolution a lot the ZK, is that we will not have to write electronics anymore, and the users will be able to use normal compilers that will compile on top of these ZK processors and execute that normally. This will open, this will change a lot the ZK, the ZK space. And we are in this transitioning space. Actually, a zkEVM is very much processor, is a VM processor.
Oh, it's interesting to hear that like you both think that like tooling is a limiting factor. Yeah, or Vitalik, do you have any thoughts about like things we want to build but we're not able to build right now with our current proof systems?
Tools, things that we want to build that we're not able to build right now. I think, I mean, there's two types of ZK, like Snark usages, right? There's scalability related things and there's privacy related things. And I feel like they have some like often pretty divergent considerations. So like, for example, like on both sides, I mean, prover time is obviously an issue, but on the privacy side, like we're talking about prover time on a user's computer, right? Like on you know, a phone inside of a browser app. And aside from that, like the applications tends to be fairly simple, and like a lot of it is just reusing very similar code bases to what have already been used. But then on the scaling side, like people generally, like for privacy, it seems to often be the case that people just want to keep one particular, like the same type of stuff private over and over again, like just proving that you're a member of a set, for example. But for scaling, like people want to make totally different things scale, right? Like there's proof of solvency, there's zkEVMs, there is like ZK other parallelizable VMs, and there's just like, it just involves writing a lot more code. It involves like, I mean, prover time challenges also, but in that particular case, like you can parallelize more, right? And so the kind of stuff that you have, the kind of code and like proof system design that you have to do to really optimize for ability to parallelize and like assume that you have hundreds of GPUs and get the answer together very quickly is kind of different from those other cases. So I feel like in both of those situations, there's a bunch of different like software things that exist to some extent, but that we have to keep leaning on and kind of pushing really hard. But like what specifically they are ends up differing between the two.
Oh, interesting. So I suppose I disagree with you about the assumption that private applications are going to be inherently super simple. That is just like proving the same thing over and over again. And I think that like the thing I'm a little bit disagree is because I feel like that's all that's been possible to do until now. Things like semaphore, like just proofs of group membership or revealing simple things. But I think that if we lived in a world where like more things were possible, people would find like more interesting things to do.
What's your favorite use case of more complex privacy stuff? Okay,
so the simplest would be an OR, that I'm an OR gate. Like I'm either part of this group or I'm part of this group. Yeah, and then you can just build on top of that with like more complicated like.
I guess like my opinions of that sort of stuff is that like all of these more complicated things that involve composition, it's like my suspicion of that category is that it makes the nerds happy to think about those kinds of things, and it makes the nerds happy to know that like, oh, you can do Boolean closures over everything, and look, it's like logic from second year university. But like in reality, like 80% of the use cases will be the most simple stuff. So I don't know if that will be true in this category, but like that would be my fear maybe.
Okay, I hear you, and like. I definitely agree with the idea that like simplicity at first is super important. That like starting out with building simple applications is important, and later we can see if in fact there are more complicated things.
Yeah, I mean I think this stuff could easily change as time progresses, right? I feel like I'm even like describing current reality than making predictions, and like, you know, it could totally be that in 5 or 10 years things will look very different.
Okay, thank you. My next question is for Ya. So yeah, I want to ask you about ZKP security. You're currently in the midst of like this massive audit for zkEVM, and I'm curious, like, are you afraid about ZKP security? Are you like, what things can we do better?
Yeah. They are like, if you are talking about the security of the owner proof, there are like multiple levels, right? Like there are theoretical level because you are using some proving algorithm. So I really wish people to use more standardized proving algorithm, which is like, you have a clear soundness proof, you have clear, complete proof. You can't do whatever arbitrary things you want. Like you need some form of proof on the theoretical side to prove that this proof system is sound and secure. And but my worry is more on the implementation side. So if you are using zero-knowledge proof in practice, there will be two things. One is on the circuit side. So because you are using different toolings, you have a totally fragmented ZK ecosystem. Like this crowd of people are using this library, and we are using a different library, and all the toolings are very hard to use. So and writing circuits is very easy to meet some constraints or even over some constraints. So that will be really hard to kind of audit. And currently, most of people still use some manual auditing, line of code and counted by that. And some experiments are, we give grants to some projects which are doing some formalification for some simple circuit. But it's very hard to do formal security proof formalification or whatever toolings you are using to formally verify that your zkEVM is secure. So that will be very hard on the circuit side, because I think very few people realize that, because more and more people are coming into this ZK space, right? Like people are kind of, they can spend 2 days learning Circom and write a ZK circuit, but a lot of people still don't realize that, how the security assumptions behind. If you are really missing some constraints and you are using a ZK rollup, then the prover can fundamentally do something really bad to kind of break down the whole thing. So that's more on the circuit side. On the backend side, there are also implementation issue. For example, I think previously there 12-bit find some security bug in many Plonk implementations. Plonk is already very standard, right? But 12-bit still find a lot of security issues when you are implementing this fair shamir. You just didn't hash some of the commitment, but it already brings you some security bugs. So that's really make people very worried, because different teams are already using different proving system. And if your proof system has been audited, then it might really cause you some security bug. And another thing which I think is really important is that people usually ignore the security problem of zero-knowledge proof because security is not so explicit. Because people care about how fast their zkEVM can be, and its proof generation time is 5 seconds versus 1 minute, but they don't care about what's the trade-off. If you take 1 minute to generate proof or 10 minutes to generate proof, maybe you are more secure. And so people don't really care about that because they care about user experience and they care how fast. So the matrix become very single dimension, which is extremely bad because we really need to educate people. If you are in Fry, then some of your security actually come from this hash, from some other assumptions, and which I think people already previously find some security issues for how many security bits at that Fry had. It's not you have this nice post-quantum security, but you also need to read about how many security bits you have in a normal world. And also, yeah, that's a big issue. People need to be really care about because sometimes you can configure, even if it's the same proof system, you can configure different parameters to have very fast prover, but maybe a slightly smaller security parameter. So that's something which I think different projects need to be more transparent about and educate people what you are really trusting. So yeah.
Okay, I understand. Yeah, there's a lot to be careful about on the security side. My next question is on a more optimistic note, what are people excited about? What are you excited about in the next few months or in the next years coming?
Well, of course, and besides scaling Ethereum, I mean, this is the full point of the zkEVM, and we are getting to this point and think that we are, rollups are something that are a real thing there. So we finally will have scaling Ethereum, and I think this is very exciting by itself. But besides that, there are other applications that for me I'm very excited. Here is, for example, all the identity applications, self-sovereign identity, where you can hold your own data and you can prove anything about your data and things around that. I think this is very important application. Voting, voting and governance systems. Anonymous voting, I think, is an important, interesting application I'm very excited on. There's many people working on that direction. There is a lot of gamings. I mean, the gamings, I think it's a full industry. You know, the decentralized gamings, I think it's a full industry that has not take off yet. And here ZK is really important for that. It's a lot. I mean, a lot of interesting things that can happen with ZK.
So I'm excited about three things all around StarkNet. The first is the performance improvements that are now coming very soon. Within less than a month, we'll see TPS for transfers of ERC20s on StarkNet in production of 100 TPS and over. In our internal measurements, we've clocked even over 250 TPS for transfers, and this is all coming next month. 2 months later, we'll have Volition with dramatically lower gas cost, and when EAP 4844 is ready, users will be able to choose from on-chain data, dank sharding, and Volition. And so that's the first aspect I'm very enthusiastic about. The second is the community that is dramatically increasing and doing terrific work. Projects like Kakarot, who spoke earlier, Madara, Dojo, Influence, the many teams that are already deploying on StarkNet, which is open for business. So developers out there, please check out Cairo 1.0. And the third thing I'm very enthusiastic about is the StarkNet Foundation that is setting up shop. It's already been giving grants in the StarkNet token to early adopter teams, and this will expand and increase in scope. So I guess all of this, yeah, please check out StarkNet. There's a lot to be done there, and we need an even greater community.
Yeah, I think for me, like what very excited me, like as Jordi mentioned, like prover keep being optimized. Maybe eventually we can generate zkEVM proof within 1 block time, which means you can use zkEVM on layer 1, like because you can generate this proof really fast. So I think there will still be a huge improvement on the proof system side. There are clearly already two trends. Like one is based on the KZG's homomorphism, you 4 different instances, like people are really crazy about. The other, like you keep moving to smaller and smaller field for Fry. And I think, it's more and more clear that there will be some path for people to go into and standardize their proof system. So I'm very excited about that. And I think a lot of things will happen, one depending on another. Another thing is about ZK hardware. Like there are a lot of ZK hardware acceleration companies or explorations. They are doing ASIC, GPU, and IPJ. So they can make this proof generation become even faster. So I'm expecting that some ASIC coming out to kind of make, some proof system to become really, really fast. And so we can get more adoption. And on the application side, there are more and more applications coming out. There are ZK bridges, ZK Oracle, ZK core processor, So a lot of those applications are appearing. I'm excited to see that they are being more and more adopted, making this world become more trustless. And also for gaming, they are lacking some new idea how you can use ZK to hide some information for on-chain gaming, some strategic gaming like Dark Forest, because every information on-chain will be public, and how you can do some hidden order game like user on a proof. I think there needs to be some more creative stuff there. I think a lot of things are related, and I'm very excited about the future of ZK.
Vitalik, what are you excited about?
What am I excited by? I'm excited by the infrastructure settling down to the point where cryptographic verifiability and privacy can just become defaults in a lot more applications. When instead of asking why add a proof to a thing, it becomes why not add a proof to a thing. And we're pretty far from that right now because of basically prover times. And I remembered one of the reasons for my kind of short-term, especially short-term opinion that privacy stuff is simple, which is has to be simple, which is just because of anything more complex is just going to have too many constraints, and that's a reality today, but it could not be a reality 5 years ago. And actually, I think that the example of Dark Forest style games might be the first big category of exceptions eventually. But if we can make it get a world where regular blockchain applications and users on blockchains have more privacy, and it's like a standard for, you know, enterprise databases of any kind, like including like balances on exchanges, but also lots of other things to just like be snarked and have their updates snarked by default. Then you know, that would be a really cool in a whole bunch of ways, and it would solve a whole bunch of problems.
Interesting. So, like, is this like Facebook becomes a Validium kind of direction, or
Right.
is that what you're thinking about?
I think that would be cool.
But like, in order to do that, like the users of Facebook would have to like sign their updates.
Right. Well, there's like different degrees to which you can do it, right? So like one of the more moderate things that you can do is like you can do some like zkML to just for the ranking algorithm, and like you prove that, and then you prove that against like a hash of the algorithm, and then 1 or 2 years later you release what the algorithm actually is, and that allows some kind of a retroactive auditing to happen, and that like gives a lot of security guarantees already without actually going all the way. So yeah, like to me it's definitely a like a piece by piece thing. And like the other thing you can do is like you can try to be pretty kind of explicit about what the holes are, right? It's like, you know, you give your users a key, and then you have an operation where if the user loses their key, you still have the exact same recovery process, and like Facebook still has a backup key, but like there's like a big fat red record on chain of like a recovery operation was done, right? And like even if you know, it's not fully self-sovereign, like getting to that level, like getting to that level of transparency is already like a pretty strong step. Well, probably step 2. Step 1 is doing the stuff I mentioned before, right? And the more you can go, the more benefits there could be.
Okay, that's an exciting potential future. Like a lot of the applications that we're talking about or use cases we're talking about, like depend upon the fact that ZKPs are programmable, in that you can make like a program, any program you can basically put it inside a ZKP, and like a more complicated program will mean the prover time will be longer, which is something that we're optimizing for during this discussion. And I'm curious, like there's other kinds of programmable cryptography in the world that like haven't really gotten the same level of adoption as zero knowledge proofs. And I'm curious, like, if people on the panel are excited about a certain kind of programmable cryptography.
I mean, it feels like the big programmable cryptography that's not ZKP is that people sometimes talk about is MPC, right? Like, there's others, but that seems to be the clear number 2. And my impression is that the biggest problem with MPC in practice is, like, you have to agree on this set of people to actually run the thing. And, like, that creates difficulties for new projects to get in and build things, that creates controversies. Like it's basically the same kind of controversy we had around a trusted setup, except instead it's a small group of people, and instead of trusting them once, you have to like trust them forever. And they can cheat undetectably, right? Like if the NSA compromises 2/3 of them, then they can you know, reconstruct, siphon off whatever information they want to the NSA, and like no one else will ever know. So the security properties that are involved with like even just being able to like identify which group of trust to trust, and then trusting the group, and then like trusting that it actually will stay decentralized and all of those things, like there's hard social problems involved. And just like given how much happiness like we've brought developers just by, you know, going from per application setups to universal setups, and then from universal setups to no setups, like if those 3 are like over here on the spectrum, then like MPC is like all the way over here, right? And so I think that's where the fundamental difficulty is. Well, like if for specific applications you can surpass it, then you know it definitely has a lot of benefits too.
Yeah, I think that like there's a bunch of applications where it's just like a peer-to-peer MPC, where instead of having like everybody agreeing on a certain shared state, I have a shared state and I'm trying to do a computation with you. Like one example of this is like ZK machine learning, where I have a database of health records, you have a neural network that you want to train on those health records. I don't want to show you the data, you don't want to show me the model. and we use MPC to do the training together.
Yeah, I think you're right. Like, I think like garbled circuit type 2 of 2 stuff, I'm very bullish on. I think the stuff I'm less bullish on is like trying to create like global MPC sets that you have to try to convince an entire community to trust.
Yeah, I agree with that. Programmable cryptography.
Yeah, so from my view, so one thing like which I want to add, also related to this question and related to privacy discussion previously, that many people still haven't realized that, zero-knowledge proof can, the privacy that zero-knowledge proof can provide you is only on the prover side. So the prover need to know all the information to generate proof. So it's not really the secure computation, which, your secret is known by a lot of people and they are doing some joint computation. Zero-knowledge proof can't do that. You have to know like all your secrets. So that's why it's very hard to make EVM compatible with privacy. Yeah, and as for the other crypto primitives, like there are FHE, there are MPC, and there may be SGX. I think in terms of the programmability, I think MPC is actually in some sense quite similar to ZK. They are constraints because the fundamental gadgets of multi-party computation is also addition and multiplication, but you just need secret sharing, homomorphism to add different secret shares, or use Beaver triple or whatever to multiply different secret shares. But the front end, the application side actually can reuse either the same compiler. Like there are some academic work talking about how you can use one like universal compiler IR to kind of like build once and then you compile down to ZK, MPC, and even SMT solver to kind of that special constraint. So I think in terms of programmability, I'm also very bullish on MPC, but as Vitalik mentioned, like MPC has totally different assumption. Another issue not related to the validator set is that the liveness of MPC is also very different from blockchain. Like blockchain needs, like people, like nodes can, go offline or whatever, but MPC rely on all the node to online for a lot of like messaging, and they need to compute something together. So that will be very, like why it's hard to adapt MPC directly to this blockchain space. And then in terms of homomorphism, I think, yeah, like homomorphic FHE, then it can provide a much stronger privacy, but it's not verifiable. But if you add FHE to ZK, then like your overhead will be significant. You still need much better like prover to make that happen. Yeah, I think there are a lot of like more interesting applications showing up using SGX, either for generating some additional prover, like add some additional guarantee. Like even in zkRob, like there are some idea for using multi-prover, like where you generate ZK proof and also SGX proof, and you need to verify both proof to know that it's secure. So it can help as a training wheel to help you like remove some security assumption. And also there are some idea using SGX to like Flashbot is using that for some other use cases, which are also quite interesting. But I know like a lot of crypto people really hate SGX because it's like a cheating box where it can do everything. So yeah, that's my general opinion. It's very interesting, but it's very early, and like you need some other efficiency improvement for other like primitives.
Maybe hate is a strong word, but like definitely very concerned about it.
Like some people, very few, yeah.
Yeah. What do you think, Jordi?
For me, the programmability is what I said before. So the interesting part is when it's not something, it's not cryptography itself, is when you can write a program with Rust and you have the proof that this program executes correctly, that you have a proof of execution of a normal program. This is for me what it's the game changer.
But like the problem with that is that like a lot of the time the prover performance degrades a lot when you have a compilation step.
But this is, I think that this will get lower every time. I mean, it's a matter of time, but it's there are new GPUs, ASICs, new hardware.
Yeah.
So it's something that I think that we'll see
like
very soon.
With ZKPs for sure, but with like MPC and FHE, like are we going to see the same trends?
It's a matter. I think it's a matter of time. I mean, this all, step by step, it will come. All these new homomorphic encryption. I mean, was something that was unrealistic to think about 5 years ago. Now it's getting a little bit better, but not much better. But why not in 10 years we'll have computers that run homomorphic encryption.
We will have FHEEVM in 10 years, maybe not. Eli, what do you think?
So if we talk about programmability with respect to scalability or the use of scalability, then I think that Cairo and systems like it give a very interesting example of virtual machines that basically take as their main constraint the generation of proofs. And we'll probably see more evolution along that. If we're talking about privacy, programmability and privacy, then I think in the near term we'll see two things. One is Zcash style limited functionality, I mean in Tornado Cash and things like that, where there's a very simple limited functionality for which you have very good end user privacy. And there the biggest challenge, which is a really non-trivial challenge, is making the UX digestible by users. That's the biggest challenge. The other kind of privacy I think we'll see in the near future is this good enough mid-ground. How does it look like? You have, as an end user, you have full privacy from the rest of the world, but you choose a centralized operator of your choice, and you reveal information to that operator. And then that operator will generate zero-knowledge proofs for those computations. I think it's a very good sweet spot for the next things, because in most cases, users will be fine with this sort of privacy, and it's like good enough for them, and you'll have very, very good UX, because from the end user, you'll just have simple interfaces just like you have, let's say, on Ethereum. And some of the StarkWare systems that we use with our customers already offer this to their customers. Customers do have privacy from all but their operators. There's a small caveat that we don't have ZK Starks, we have plain Starks, but you could make that ZK and even give the formal assurance of zero-knowledge proofs. Further down the line, I think that MPCs are not coming anytime soon. And the reason is because of the interactive complexity, the round complexity, and that increases with the complexity of the circuits. You can't have Turing complete architectures like Cairo or EVM. They break very quickly under MPC, so you're basically restricted to circuits, and you pay very dearly in the number of rounds with the complexity of the circuits. So because of all this, I don't think we'll see them anytime soon. And if we will see them, and this is a really cool research problem, is how to bring in economic incentives into the interaction that is necessary for secure MPC. So this is an area that has not been researched. Cryptographers have not looked at it. But if you throw into the model the economic incentives, then you start to get very interesting things. So maybe a way to make progress on this would be to come up with a protocol that also puts, you stake some things and you have to walk through the steps or else you get slashed and things like that. That might be a way forward, but still, I don't think in the next 5 years we'll see secure MPC.
Okay, thank you. So since we're at EDCON, my last two questions are about education. So the first question is for new people wanting to get up to speed on ZKPs, how would you recommend that they get started?
What I recommend them is just go to Snark.js and do the tutorial that's in there. You will create a full circuit, you will create a proof, you will verify the proof, you will verify the proof on chain, and I think this is a very good starting point. In 1 hour, you can do this tutorial and you can have a good idea of what means programming a circuit. Of course, from there is a lot of literature and a lot of things to read, but I think this is a very good starting point.
I can go. So it depends what you want to understand. If you just want to get the high-level spirit of what ZKPs can offer, then I often recommend, I think Vitalik explains everything very, very well, including Starks and Snarks and ZKPs in general. So you can read some of his writings. Also on the StarkWare site, we have our own writings about ZKPs. If you just want to experience their power, I think the simplest route is to go to StarkNet, do hello world on Cairo, and then abstract it away, you already have proofs generated for you. So it's really a question of what you want. And then if you really want to understand them, then there's no other way but to start reading some very heavy material in cryptography and theoretical computer science. It's not something simple, but still.
Yeah, so yeah, it also depends on whether you are just want to develop some ZK application. If you want to develop some ZK application, I would just recommend you following either CirCom, Halo 2, those we have hosted a bunch of workshops and understanding how to use that. I think the best way is just to trying to use and trying to hack it, and then you will figure out how to write circuits, and you look at some what other projects are doing, look at their circuit code and understand better how to write a circuit. And if you want to go deeper, you can check out some kind of, read some very new, recent paper and talking with people and attending some conferences and figure out what's the problem that industry is looking into. Like, for example, people are looking into folding, then you need to read some recent folding paper and figure out, what people are looking into, what problem have been solved, and trying to, figure out those problems and talk with people. And if you just want to get a very comprehensive understanding, there is also some book from Justin Taylor, which is a very comprehensive book. Yeah, I think another thing is also what we are doing is that we are hosting some bi-weekly ZK application discussion, which a lot of applications will present their application into very detail, how things work, and you can check out those videos and understanding better how those applications work. Yeah, and also there are a lot of online resources. I think a very good one, besides ZK podcast, is ZK Study Club. ZK Study Club, by the way, is a really good resource for you to learn deeper about papers. There is also ZK Hack, where because hacking something can really think of if you think from the other side, how I can prove something, generate proof for something which is not provable, you definitely understand why something is provable. So I think hacking that is a really good way for you to understand. Yeah.
And then if, as a developer, you want to really go down the deep end, at some point you can try implementing your own prover and verifier for one of the ZK Snark schemes. It's actually somewhat less hard than it seems. It's still very hard, but it's somewhat less hard than it seems.
My advice is to try not and be intimidated, that all of these ideas boil down to simple intuitions, and the struggle is just to get there. But at the end of the day, it's a lot of simplicity. So we have a little bit of time left. My last question is for all the people on the panel. Everyone on the panel is at different stages in their ZKP adventure, in their learning and exploration of what's possible. And my question is basically, if you had to start again, what would you do differently?
Sorry, can you repeat?
My question is that if you had to start again on your learning exploration, what would you do differently?
I would do the same thing exactly again. Sorry.
I would come up with the concept of Fry in 2012.
I would do the math career at some point.
You would study math?
I would study math. So as an engineer, engineers, we have, I think, a good degree of understanding the math, but when you go deep to the cryptography, and here Lee and the cryptographers, it's getting hard and it's getting tough. And the foundation of engineers, I would say, it's enough for implementing and for using it, but having a better foundation in math is something that helps, and it's something that if you ask me, I would study more math when I was young.
Yeah, for us, I think because being open and community-driven are two important values we always have. I think we even want to make that more open, which means more community-driven, which means I think we even need to spend more time, our developer, our ZK circuits, besides their normal, ZK engineering, zkEVM, who is the first zkEVM. They also need to spend much more time thinking of dev tooling, how to make like more people like writing circuits like way easier, because currently writing Halo 2 circuits really suffer. You can have a lot of configurations, but it still suffers. Like how you can improve this efficiency to make even more people to join your ecosystem, join this open source community, and keep constantly thinking of how can we make everything more transparent and more open and more community driven. That will be our goal. We already start doing a lot of workshops and a lot of dev tooling. There are already being a lot of people even building more convenient toolings, like XM is building Halo 2 lib for people to write circuits. It's a lot of things are happening in this ecosystem. We want to make that bigger and bigger. Then there will be network effect. Like you have a lot of gadgets implemented, even more, and then hardware might want to support this framework. So that's something which we are already doing, but I think we want to do like a lot more.
I think my serious answer is that it'd be I'd be less scared and more willing to just go and do things.
Barry, could I modify my answer? So if I had the time machine to go back, so I still stand that I probably would have done everything the same, but not related to proofs. So I think it was in 2014 or maybe early 2015, actually Vitalik reached out and said, do you want to read the yellow paper, comment on it, and be more involved? And I said, no, I'm not interested. I don't have enough time. So definitely, that I would have done differently.
So my answer to this question is that, kind of what we spoke about a little bit earlier about simple things being super important. I would worry. I find a lot of the times I get sucked into this rabbit hole of just optimizing things, and when I go there, it takes me on this journey that I don't need to go on, and it's actually kind of harmful. That I think that I sometimes over-optimize things.
I think that's true, though. I think there is an aspect of this which is sort of the fault of the researchers more than the fault of the newbies, which is that often I find the researchers end up only writing out the optimized version of the thing and not bothering to read out the noob version of the thing, which is maybe 2 times less efficient but 10 times easier to understand. And I know in my intellectual journey, first understanding the noob version and then understanding improvement by improvements would have helped me get toward understanding things much more quickly. So that's something that I would love to see people on the research side also doing more of in the future.
I hear you. Another thing that I think is becoming more important is product thinking in the ZK space. That up until now we've built a whole bunch of applications largely as research projects, but to actually get to the point where we have Facebook as a validium, we need to transition to more user-focused thinking. So we have a few minutes left. Does any of the panelists want to ask some questions?
Yeah, maybe from the audience.
Questions from the audience is good too.
Does anybody have a question for our panel?
There's someone way up there. You probably need to come down, I think, too. Or you can throw the mic.
Oh, thank you. Hi, I'm from China. My name is James. And so I'm just wondering, so Squirrel is one of the top 3 players, right, or top 5. I'm just wondering when is Squirrel going to launch the mainnet? And what's the vision for Squirrel?
Panelists, what is your vision for Scroll? Jordi, please go first. For Scroll.
Yeah. Look, well, first of all, Scroll is an amazing project. I mean, they are building a zkEVM. Right now, I think they are just thinking a lot in the being a type 1 zkEVM very much. It's a project that So it has been very engaged in the community, has been built very much from the community perspective, and it's fully written in Rust. Of course, if you ask me, you probably, we did the things different. I mean, we had different architecture and different approach, but I think that we learn a lot each other. I can tell you that we learn a lot of Scroll in the way they're doing the arithmetization, and the fact that it's an open project, an open source project, and this helps a lot. The collaboration means the contribution, the learning one each other. You need to think that doing a zkEVM is not an easy task. No zkEVMs exist before. I mean, this is something that's really new, and it's not a single way to do the things. I mean, when you're doing engineering, you need to take a lot of decisions, and some decisions sometimes are good, sometimes are bad, and there are even some decisions that, depending on the time that you take it, you can be in, because you are taking this decision very early, you can go to the wrong path, and then you have to go back and move forward. And the fact that there are not only Scroll, but many teams, many people in the space working, trying to build the same, but with different optics, with different perspective, with different ways, the freedom to do it, because this has been very, very, very helpful. Sometimes, I mean, I would like to increase, and my question is how we can do to increase this collaboration and to increase this knowledge transfer, not between Scroll and us. I mean, between Scroll, between zkSync, between Takeo, between Gnosis people, between all. I mean,
StarkWare.
Yeah? StarkWare, of course, yeah. I mean, but StarkWare is zkEVM. Well, yeah, it's zkEVM. But yeah, but it's,
I want to say,
look, we are using all the technology we are using in Polygon is mainly Starks. I mean, if this guy would not create Starks at this point, the Polygon zkEVM would not be possible at all. It would be a different thing. So, and this is the cool thing. This stealing, if you want to call it that way, this borrowing ideas and borrowing concepts and learning together. This is what allows us as a community to go faster, and we need to understand that. And here for me it's a call, special call, especially for marketing peoples and product peoples on that. Technical people, we are in the same, we have the same goal. We want to scale Ethereum, or if you want, we want to scale blockchains. We believe in this technology, and we want this technology to happen. And if we don't understand that we need to collaborate together, so we are going to go at least slower. And this is hard, because I mean, when you see some people in the same in your company that's just fighting in there, it's hard. And we need to do the effort to keep contributing, to keep collaborating, to be meeting, to keep asking questions, and to keep, and this is the sense. And I'm working hard, I'm trying to work hard on this direction. I believe in this. Sometimes it's hard, but this is what I believe in. And Scroll, I mean, you can say in your own voice, but this is the open source spirit, and if you want the Ethereum spirit that we want to grow together.
Thank you, Jordi. Okay, so we're out of time, but I just want to let Zhang have the last word for the question. I'm sorry to joke around. I think the question was like, what's the vision for Scroll?
Yeah, I think Scroll want to, be truly accessible, be truly decentralized, build a bytecode-level zkEVM, and also not only building, technology-wise, you are scaling Ethereum, but you also need to inherit all the good values that Ethereum really has, like being open, being community-driven, being incredibly neutral. So that influence a lot, like how we develop our zkEVM, like when you open source, whether you open source from day 1 or day 100, like whether you prioritize community contributions or you want to just ship path. So a lot of things related to our decision making. And, but I think we will always uphold those values we have to build the, zkEVM. And also, like, we are very collaborative with, I think, every conferences we met Jordi, and we discuss a lot about, how we can improve this, what's the security problem. We even hold some kind of security audit, sessions together to teach people what's the difference and, make that more secure. So.
Yes.
Okay, thank you, everybody.
Quick question.
Oh,
Yes.
Oh, okay. Do we have time, I guess? Sorry.
Yeah, so in my last weeks of exploring end-user application, when trying to build something a lot more powerful, I saw myself going towards more using blockchain just as something that holds the state in a decentralized way, but doing the most complex computation outside and just proving state transitions, for example, with zkML. And then I questioned myself, like, oh, a lot of people are talking dApp chains where you need to do computation on chain, but with ZK, you might have like same security as a blockchain in terms of computation itself. And I'm just curious about like how do you see the future of like a lot more complex computation? Because I see like even if you do it on a private server and then you just prove and you have the state on chain and you just do the state transition on chain, that would be sufficient. And I'm just curious about like how do you see like, do you still think like blockchain computation is necessary, or is it enough to have states and do the computations on even private servers and just prove it on chain?
Okay, so the question basically is, like, if ZKPs get powerful enough, do we need to have like a blockchain, or is a world where we just have proofs that everything is correct enough? So let me try and give my answer, and then I'll open up to the panel. So like my answer to this is that like ZKPs give you validity, but they don't give you like data availability. That like there's no way to know that like the data that you need to make the proofs has been published unless you publish the data. And that's kind of like the idea. Like for me, that's a central problem that blockchains try to solve. The hardest problem is a data availability problem. And for that reason, I think that there's a really nice interaction here where like blockchain solves data availability and ZKPs or fraud proofs handle validity. But I'll open it up.
I think, so I referred to this a little bit in my talk this morning. So if you think about what a blockchain does, it gives you this very high level of integrity through very good social consensus and some distribution of values to operators, okay? And then what validity proofs allow you is to invite arbitrarily powerful operators to bring on more computation that is done not within the scope of this thing, without taxing all of those operators, but having the same level of integrity. Now, it's true that if you want to save data, you may want to save some of it or all of it on-chain, but for the processing, you can sort of dramatically broaden the scope of integrity that a blockchain gives you with the use of validity proofs, and you can do so even recursively. And that's exactly what I think all of us L2s are going to do to Ethereum. By the way, I just want to say later on, if we have time, there's a question there that I don't know if we have time.
Okay, one last question from the two ladies with their hands up.
Thank you. Do you mind passing around? Thank you. So my name is Gwen, and I'm quite nervous at the moment. Yeah. So I'm from Orbiter Finance. So I would like to hear your guys, the point, like your view on the cross rollout bridge, because basically we support like Scroll, Starknet, and Polygon zkEVM and zkERA as well. So yeah, what's your point on like mainly the security of the cross rollout bridge? Thank you.
So this is an important question that comes up because people see cross blockchain bridges like layer 1 to layer 1 being hacked all the time, and it's a very big concern. And the reason why we did all the work to make like ZK and optimistic rollups is because the bridges have like fundamentally better security. Because instead of being based upon trusting like a set of people in a multi-sig, it's based upon verifying that you have cryptographic guarantees that the state transition has been happened correctly, and that no one is able to steal anyone's money. So like my opinion is that like roll-up to roll-up bridges will be fundamentally more secure than like layer 1 to layer 1 bridges. But I'll open it up again.
Yeah, there is one thing that I think here we have a kind of a naming problem. We are referring to a bridge to 3 different things that have nothing to do, in my opinion. Well, they are bridge maybe from the user perspective. But one thing is, I would say, a trusted bridge. That's probably what we understand. We have 2 layer 1s, and then there is some kind of multi-sig or whatever that's just approving from going from one side to the other. Okay. Then we have this trustless bridge, which is there was a word that now I don't see it very used, but time ago people used a double pegging between 2 chains. I like much better this idea, but the idea is that there is no, I mean, it's automatic, there is no intervention, there is no multi-sig, it's just
atomic swaps between chains.
Yeah. Okay. And then the other would be between rollups, but these rollups goes more in this double pegging category, which is I mean it's you don't need, it's a smart contract. It's just it's a bridge because it goes from layer 1 to layer 2, but it's a different thing of what people understand from a bridge. People hear bridge and they think about this committee of approving things. So here I like more the double pegging and roll-ups. I would not even talk about bridge. I'm just transferring from layer 1 to layer 2. So it's no bridging. I mean, it's just we're in Ethereum. You are sharing the security of Ethereum.
I agree that we should have another name for the bridge from layer 1 to roll up or to layer 2. Any other thoughts about this?
Yeah, I think another thing is depending on how the bridge is implemented. Recently, there are some efforts implementing some ZK bridge, which actually ZK snark the consensus or whatever like the other chain have. But it's still like fundamentally different from zkEVM because zkEVM proves the whole computation and then verify through smart contract, which all rely on this Ethereum's validator set. But even if you use use zk snark and the other chain, 2 chains still fundamentally have different validator set. So you can make sure that all those validators are agreed on some kind of consensus about this chain state, but it then depends on like Ethereum's validator set. So the problem that layer 2 or zkRAP solve is that we can move trust to smart contract on Ethereum, which we can reuse all the Ethereum's validator set. And another strong reason why even like doing this cross-chain bridging, there are some idea for if you are to zkRAP, maybe you can read state root through the same chain on smart contract and then like doing some more trustless operations. But that's another different, maybe need a different name than like those cross-chain bridges which have totally different validator set. So I think the fundamental of layer 2 and the trust of zkRAP come from the base chain, the same validator set or smart contract. It's not from the other set or whatever. And zkRAP can provide you this nice publicly verifiability, which like the public is all the Ethereum validator set. Yeah.
Okay, thank you everybody. Thank you. Let's thank our panelists again and have a nice day.